Welcome to the ADS Workbench video tutorial series. In this lesson, we will be learning how to use the ADS Workbench to configure a 3D multi-row time-accurate simulation. Before starting, you should have already created and run to convergence a 3D multi-row steady simulation of the case of interest. If you have not done so already, please create this case. If you have questions, you can refer back to the 3D multi-row steady simulation tutorial. Now, there are advantages to running a multi-stage case to convergence before starting time-accurate simulation. The greatest of which is that it improves overall simulation time, and it will also improve the accuracy of the results. When it comes to 3D time-accurate simulation, the name of the game is to get useful information with as little compute resources as possible. This is why the Workbench will choose to simulate the minimum number of passages per row that will still keep the integrity of the simulated results. The case we will be running today is the 1.5 stage turbine that was included as a sample. This 1.5 stage turbine has a first vane that is made up of 20 passages. The first blade is made up of 30 passages, and the second vane is also made up of 30 passages. It would be insane to run a time-accurate simulation of the full 80 passages. Instead, the Workbench will select the lowest common denominator of passages to simulate. In this case, it is 233, or 2 passages for the first vane, 3 passages for the first blade, and 3 passages for the second vane. If your case cannot be split evenly, ADS provides a utility that will allow you to scale and reduce the number of passages per row such that the case can be divided into something that you can reasonably run. Please refer to the ADS util documentation on how to set this up. Time-accurate simulations are best when run in parallel. It is not recommended to run a time-accurate simulation serially unless you really want to wait a very long time. Now that we have gone through all the formalities, let's start the Workbench. Let's first take some time to review the workspace. In the Project Explorer, we have 3 single-row cases, row 1x representing the first vane, row 2x represents the first blade, row 3x represents the second vane of our 1.5 stage turbine. Let's verify the number of passages per row. The first vane is made up of 20 passages. The first blade is made up of 30 passages. And the third vane is made up of 30 passages as well. Next is the 3D steady simulation that we have for this case, called Turbine 1.5. Inside Turbine 1.5, we can see that we have a converged solution. There is a restart file here called row1x.rest. Now, setting up the 3D time-accurate case is really easy. Just go to File, New, 3D Multi-Row Time-Accurate Case. A new window will pop up asking you to select a case name. Let's call it Turbine 1.5 TA for time-accurate. And let's put it into the samples project. The next thing to do is to select the 3D steady parallel case. In this case, we will select Turbine 1.5 and click OK. Now, once you've selected the case, you'll notice that the 3 parameters here have been defaulted to ADS recommended values. There are the total inner iterations per time step, the number of time steps per cycle, and the number of total time steps. The number of inner iterations per time step is the number of inner loops that the flow solver will execute before moving on to the next time step. ADS recommends 20 inner iterations per time step. The number of time steps per cycle represents the number of time steps for one blade passage to completely pass the following vein. ADS recommends 450 time steps here. Now the total number of time steps is the amount of time that is executed for the case. Here, ADS recommends executing 4 cycles worth of time steps, which is 450 times 4, or 1800 time steps in total. We're going to keep the defaults. Let's click Finish, and you'll see a new directory appear. In this new directory, you'll see that if the build was successful, that there are a total of 8 restart files ranging from row 1x passage 01 through row 3x passage 03 and the corresponding Leo files. If we click Run Leo Solver, we will see it start to execute. I'm not going to wait for this to finish, but it should complete in less than a day. Thanks for watching this lesson. If you have any questions, please visit us at www.aerodynamic-solutions.com and check out ADS University and the FAQs. If you do not find your answer there, join the community forum and post a question. Good luck!